Hello friends, let's do another question from electric circuits and network. Here, this question is based on Thevenin's equivalent circuit. The question, a battery charger can drive a current of 5 ampere into a 1 ohm resistance connected at its output terminals. If it is able to charge an ideal 2 volt battery at 7 ampere rate, then Thevenin's equivalent will be. This is a question. From the question, let's draw the circuit based on the information given. In the first sentence, it is given that a battery charger connected to a 1 ohm resistance and 5 ampere is flowing through it. So let's draw it like this. Since it's a battery, I took the battery voltage as VB, and also it is a battery charger. It will be, that is a practical one, and so it has an internal resistance of R in, that is denoted by R in. Then it is said that it is connected to a 1 ohm resistance and 5 ampere is flowing. From the first circuit and the first sentence, information given in the first sentence, I draw the circuit and wrote the equation as V is equal to IR formula. Using that formula, I wrote as VB equal to 5 into 5 ampere current into R in plus 1. Resistances are in internal resistance of battery plus 1 ohm resistance given. From which the equation 1, we got this equation 1, VB equal to 5 R in plus 5. Now let's see the second portion of the question. That is, if it is able to charge an ideal 2 volt battery at 7 ampere rate. Since it is given as ideal 2 volt battery, we don't want to consider the internal resistance. Okay, for ideal 2 volt battery, since it is ideal one, we don't want to consider the internal resistance for that battery. And 7 ampere is flowing through that circuit with the same volt battery connected to it. That is VB, internal resistance of battery charger, and 2 volt ideal battery is given, ideal voltage is given. Then 7 ampere is flowing through the circuit. With that information, we draw this circuit, and with that we can write the equation as VB. Since the current is flowing from battery charger to the ideal battery source, so VB minus 2 divided by the R in equal to 7 ampere. That is, hope you understood how I wrote this equation. VB means the current is flowing from VB to 2 volt. So we wrote VB minus 2. Then voltage divided by resistance is current. That's why we divide it by the internal resistance and we got the current as 7 ampere. And again we rewrite the equation as VB equal to 7 R in plus 2. This can be taken as second equation. From first equation it is VB equal to, and second equation also VB equal to. Therefore first equation equal to second equation, since both are with respect to battery voltage VB. Now from first 1 and 2, R 5R internal plus 5 equal to 7R internal plus 2, from which we get R internal as 1.5 ohm. Take it as equation number 3. Now we can put this R in equal to 1.5 ohm value in the first equation. From that we get VB equal to 5 into R internal is replaced with 1.5 ohm plus 5, which is equal to 12.5 volt. Now the question asked is, draw the, no need to draw, but we can find the Thevenin's equivalent. That means for finding Thevenin's equivalent, let's draw the circuit as the VB is 12.5 volt, which can be taken as Thevenin's voltage, and the internal resistance is 1.5 ohm, which is Thevenin's resistance, and whatever the load resistance they give, that can be written here as RL. This is the Thevenin's equivalent circuit, that is 12.5 volt connected in series with 1.5 ohm. This is the Thevenin's equivalent circuit. From the options, we can find that option B is the right answer. Let's see the options. In option B, it is written as 12.5 volt in series with 1.5 ohm. Okay, option D also having the same values, but it is written as parallel. But in Thevenin circuit, we know the connections are in series. So option B is the right answer. Hope you understood this question very clear. If you have any doubt, please ask in the comment section. We'll meet with another question in the next video. Thank you. Have a nice day.